Okay, this next section for volume is 7.2b. So this is finding volume by the washer method. And we can also think of these as circular rings. Before, what we were doing with this method was we were adding infinite numbers of cylindrical disks to get to the volume of an object. But now we're going to be adding infinite numbers of circular rings to get to the shape or the volume of our object. So first, let me just point out something that we all already know to kind of gives us something to look back on when we look at the formula. If ever you want to find the area of a ring, then what you do is you have to find the radius from the center of that object to the outer ring, and once you find the area of that outer ring, you also have to find the radius of the inner ring, and you have to subtract it out, right? If I want to find the area of this shaded region, I have to find the area of the large circle, find the area of the small circle, and then subtract it. Once I subtract out that whole, then I'm left with the outer ring, which will provide me the area that I'm looking for. Okay, so we're going to be taking this concept and applying it with the washer method. Okay. Now the way that we can tell whether to use this method or washer method is you first start off by looking at your shaded region in relation to your axis of revolution. So this is from the last section where we have y equals square root of x between 0 and 4. Axis is y equals 0. Okay. Notice the shaded region compared to this axis. Okay. We don't see any gaps. This shaded region is right up against this axis for every point that we see. Okay. There's no gap in between. So when this is revolved around, there's not going to be any gaps. There's no holes within this object. Okay. Now let's move on to an object that's a shaded region that's created by this leaf-looking shape. Now this is starting at the origin, okay, and let's say we're wanting to take that object, we want to revolve it around the x-axis as well. But notice that this object, this shaded region, is not up against this axis except at 0. So you see there's this gap here that you don't see with this shaded region. So because of the gap, and if you can imagine this object, this shaded region revolving around the x-axis, and here's a series of pictures to show what the resulting shape will look like. We see that we're going to come up with kind of a bowl-shaped figure, and there's definitely a gap, a hole that is between. Now the hole is not going all the way through, but anytime you have a gap or a ring-shaped figure like this, then we know that we have to go through washer method, meaning that we have to subtract out a portion of this object if we want to find the volume. So here we don't have to subtract anything out. There's no gaps, there's no holes, but because of these holes and gaps, we have to make sure our volume formula reflects that, and we have to subtract out that hole. Okay. Let me walk through a problem here, and then we can go through the steps. So this figure here, we're going to expand that and look at this problem. So let's say this leaf-shaped figure is created by y equals square root of x, and y is equal to x squared. Okay, so we see the shaded region here, and we want to revolve this around the x-axis. Okay. We have now two components that we have to be concerned about. We need to find the big radius and the small radius. So this goes back to what we know with geometry problems that we've seen in the past. If we want to find the area of a ring, we need to find the radius of the big circle, the radius of the small circle, so we can subtract the two areas out. Okay. Okay. Once you have the axis, you're going to start on the axis and you're going to draw your radius to the further curve, the curve that is further away, that will create the longer radius. So in this case, we're going to start on the axis of revolution. We're going to draw to the further curve, and the further curve is square root of x. Okay. And that will be our formula. So we drew a vertical radius. So we do top minus bottom. The top of this radius is hitting square root of x. The bottom of this radius is hitting 0. So square root of x minus 0 is square root of x. Okay. Now, to be concerned about the whole, we're also going to start on the x-axis. We're going to find the small radius by drawing the this new radius from the axis to the curve that is closer to the axis. So we see that this will be the smaller radius, and we can also do top minus bottom because we drew vertical radius, vertical rectangles. So top of this radius is hitting the x squared, and the bottom is hitting 0, so x squared minus 0. Okay, so we're taking this idea of area of larger circle minus the area of a smaller circle and adapting it for this washer method here. Okay, so the formula is pi, lower bound to upper bound, r squared minus little r squared. This pi is factored out from both of these radius. So it's technically pi big R squared minus pi little r squared, but we can just factor out that pi and not have to write it twice. Now, a common mistake that students make is that they want to draw a radius between these two curves. Okay, and but the problem is if we draw a rectangle between these two curves, then that's no longer the radius, right? Because the radius has to include the center, right? If the axis is the center, then any radius that we create has to include this line. Okay? Just like over here, if you were to find the radius of either circles, you would not draw between these two circles, because that segment will not include the center, and so therefore not the radius. Okay. Upper and lower bounds are from our left x value to our right x value. So in this case, it's from 0 to 1. And we plug into our formula here. So big R squared is simply square root of x squared. Little r squared is simply x squared, quantity squared. We can go through power rule and expand and plug in upper and lower bound. 1/2 minus 1/5 is simply 3/10. And we don't want to forget the pi. So 3/10 pi cubic units. Okay, so much of the formula will look the same from between this method and the washer method. The only thing that has changed is now we have to account for this hole that we want to subtract out. Okay. Again, if you see a horizontal axis of revolution, you know you do top minus bottom. Everything's in terms of x. If you see a vertical axis of revolution, you know that everything will be in terms of y, and we're doing right minus left. Okay. So the steps here are very much the same. A couple of important reminders. Again, make sure that both your radius, big R and little r, they have to connect to the axis of revolution. We need to include the center if we want to draw the radius. Never draw the radius, big R and little r, between the two curves when finding volume, because if we do that, then that's no longer the radius. And the way that you tell which one is big R is that your big R is always the longer in length than little r of x. So once you draw your two radius, Okay, preferably next to each other, close to each other, so you can compare their lengths. The longer length will be big R, and the smaller length will be little r.